This is problem 77 from section 7.5. As you can see, it says a person throws a stone into the air. The height in feet is given by the equation shown. Part A asks, what is the height of the stone after 3 seconds? Well, that's simply saying t is equal to 3, so we will simply enter it into the equation. Personally, I think it's best to put the equation into the y equals rather than just figuring it out in this screen. So you should enter the equation. You can see it there. Then you can either use trace. Now, I don't especially like trace. It has to draw the graph first, etc. And just enter the 3 here, and you'll see that it is 16 feet. Or you can use table, which is second table, enter a 3 here, and we still get 16 feet. So there's part A. Let's move on to part B. Part B is asking when is the stone at a height of 30 feet. Now, the first question was pretty easy. They gave you an input of 3 seconds and said, what's the output? Now, every other question with a quadratic really relates only to about 3 questions. The information that you're asked for in quadratics, there's the quadratic formula. You'll either be asked for the y-intercept, and that's pretty easy because it's just c, so it's the point 0, c, because we found out that you set x equal to 0, which makes these two cancel and you're left with c. The other question they'll ask us is what's the vertex, but they usually disguise it with what's the maximum or minimum height, that type of a thing. And of course, since a quadratic looks like this, the maximum minimum is at the vertex. And you'll recall there's 2 ways to find the vertex. One is to use the vertex formula, which is shown here. X equals opposite of b over 2a, and that finds you the x value. If you need to know the y value, you simply plug it into the equation, or you can use your calculator. Whenever possible, I like to just use the vertex formula. And then finally, it will ask you for zeros, which are the x-intercepts. And you can either use the quadratic formula to find that, which I see I overextended this. Sorry about that. So you could either use the quadratic formula as shown there, or you can use your calculator and find the 0. The reason we call them zeros or x-intercepts is because let's say that I had this axis, the zeros hit at the x-intercept. So what does that mean when we have a height of 30? B is saying that the y value is 30. Find the height when it's 30. So we have 30 equals the equation. To solve that, we have to have it equal 0. That's why it says find the zeros. So I want 0 on this side, so I basically have to subtract 30 on that side. What we could do is we could just go into our y equals and subtract 30 on this equation and find the zeros. So that is the strategy we will use. So I'm going to put minus 30. Let's go ahead and get the zeros. Well, when we're getting the zeros, let's graph it real quick, see if it fits. It does, but it's not fitting very well. One of the big challenges is always going to be to get your quadratic or your parabola to fit well on the graph. So therefore you have to play around a little bit with the zoom. I like to use 3 things, either Z standard because that gives you a nice size grid, or zoom fit, and both of those are in conjunction with zooming in and out. It seems like Z standard is easiest, so I would always try that first. So we see that it fits pretty well here, and we'll be able to use that. If you want to zoom in, you could. I do want to show you that if we use zoom fit, that it makes it a little more difficult to zoom in on those 2 spots where it hits the x-axis, which is our intercepts. So again, you want to have your zoom set correctly before you proceed. Now, since I'm looking for when it's a height of 30 feet, I'm looking for the zeros here. So I will hit second, calculate. We're looking for the zeros. The first thing I have to do is be left of this first intercept right here. Well, notice x is 0. Well, 0 is over here on the left of this, so that's good enough. So I'll just push enter. Now I have to get to the right of this point. In other words, it looks like it's probably at about 1 or so. So I'll just move to the right till I get there. You can see, number one, the cursor's to the right, but also notice the y value. The y was coming from below, which was negatives, and it's always going to switch either from negative to positive or the other way around when it crosses the x-axis. So now I know I'm to the right. Enter. Guess. You could get close to that if you wanted, but I can just guess. So there's value 1. X is equal to 0.6, and so that would be one point in which the stone hits 30 feet. But again, the stone goes up and then back down, so it's going to hit 30 feet in a different spot as well, or at a different time. So second, calculate again. We're still looking for the 0. We just have to be to the left of this point. Technically, I'm to the left right now, so I could just push enter if I want. Notice the y value is positive, and so I need to move to the right till it gets to the right of this. And the y value is what I'm going to watch because it will become negative. And see, it went off the screen, but I know it's negative, so I know it's to the right. I'll go up here so you can see that. Enter, enter, and there it is, 2.63. So there's the answer for part B. Part C is asking, when does the stone reach the ground? Well, that would just be a height of 0. Notice that at the y-intercept we have 4. So in other words, when they first threw the stone, it was 4 feet above. And so there will only be one answer because the other time it was 0 would have been a negative value. So, where does the stone hit the ground? We would go to our y equals, and that would be where our equation is equal to 0. But recall, we had subtracted 30 earlier, so we need to delete that. So let's back up here, hit the delete 3 times, and there's our original equation. Saying it equal to 0 basically just means go to where we do calculate, second calculate, 0. Fits fairly nicely. Again, you can see that when x is equal to 0, y is 4. So the other point in which it hit 0 was a negative time, which we wouldn't have. So the left bound, we are left to this only intercept, which is right here. So I'm just going to push enter. I'll get to the right of it. Again, the y value will end up being a negative when we get to the right of it. Whoops, I just went past it, but you can see I'm in negative territory. I can back up a little bit just to show the cursor. So I am to the right of this intercept. Push enter, guess, and there's our answer. So the stone hit the ground 3.33 seconds later. So there you have it. Hope that helps.